Oh, hello everyone, and welcome to another low-tech webinar. My name's Pete Swinney, and today's subject is how to set up logging in an ECU. The topics we'll cover today, what is data logging, and we won't go in too much depth with that. It's actually a very big subject, but we'll cover some basics. Where do we set it up in the ECU, and some information on how to help you choose what to log, the number of things you can log, the rates that you can log them, how long your logging will last. And we'll also tell you how to set the ECU up to start and stop logging and how you can save that setup. So what is data logging? It's, as I said, a large subject. Effectively, data logging is the ability of a piece of hardware to record information that sensors may log, or that may be logged or measured into a device, and so we can bring that recorded information into software and view that information in a manner that's accepted to the particular user. So for instance, there are lots of different ways to look at logging. So you can look at that recorded information via what I would call squiggly lines, a little bit like what you see on the screen in front of you now. You can look at it as numbers, you can look at it as chart recorders, you can look at it probably 15 or 20 different ways. Effectively, it's a set of information that's coming from, as I said, sensors and calculated channels. In our logging software, we refer to them as channels. Everything's a channel. Create channels and do all sorts of things with channels. So the ultimate goal is to find out information which is useful, and then to take that information and make physical changes to your engine. Okay, with relations to ECUs for data logging, most people would use data logging in ECU initially anyway for tuning, and in front of you there now is what we call a time distance graph. That graph is fully selectable in Motec's case, so you can choose any of the recorded channels to appear on the screen in front of you, virtually any color and any sizing. And the example that you see there now is what I would typically set up for doing the basic engine tuning. So RPM, throttle position, manifold pressure, and lambda, which is air fuel ratio. And down the bottom we've actually got engine temperature, because there's no point in us tuning an engine when it's still sitting on the cold start. So the ECU data can be viewed like this to help customers check what their engines are doing. Another screen that you can configure with i2 is to look at a reliability part of the ECU. So, well, not so much the ECU, but the engine. In this case, this data, the ECU was recording oil pressure, and also connected to the ECU was a lateral G sensor. So in this example, we can see the engine oil pressure channel, which is where the green arrow is, and that channel is dropping badly during the log. And you can see the big dips in oil pressure also correlate to a particular G movement, and this just happens to be left-hand corners. So every time there's a left-hand corner, we can see by looking at the data that there's a problem with the oil pressure. So oil pressure low, left-hand corner. Oil pressure really low, big left-hand corner. So this way we're using data to look at other things other than tuning. So looking at making the engine live, or in this case, advising the engineers to build a new sump for this particular setup, because the sump's obviously not doing the job. We can also view data as another example here is called an XY scatter plot. And in this case, the data coming from the ECU is being all gathered into one kind of picture, and that picture is actually the boost curve of an engine. This particular engine has reasonably low boost, but this is manifold pressure or boost on the vertical axis and RPM across on the horizontal axis. And the data is actually coloured by different throttle positions. So 100% throttle, 80% throttle, 40% throttle, they've all got different colours. So we can see what boost this engine makes at what throttle position, and we can see how the RPM and boost are related. Just another way of using a data analysis program like i2 to help you learn interesting information. So in the ECU, how do we set this up? You can do this offline or online. When you're doing it online, obviously there's actually a little bit more information, which we'll come to shortly, about your logging time and the number of channels. But so for now, on this example, we'll assume we're online. The whole process of setting up data logging is about items versus frequency. So the more things you log, then the less time you will get. The faster you log things, the less time you will get. So if you log every channel, if that was possible, and you logged it up to 200 times a second, you might only have 20 seconds of data logging. The ECU has a preset amount of memory for the M400 customers, that is 0.5 megabyte, and M800 customers, that's 1 megabyte. And if you're an M880 customer, you can get a 4 meg upgrade. So depending on the actual amount of logging that's currently enabled in your ECU, this will determine how much physical logging time that you will have, which is affected by the number of items that you choose to log and the frequency, the number of times a second to log them for. So this will become a little bit more evident as we go on. So we're always constantly looking at the available time, which is down the bottom. That lets you know, and looking to see how much logging time we've got while we're configuring this up. The other thing to remember is that the ECU has cyclic logging. So what that means is, for a given amount of logging time, let's say at the end of this exercise we come out with 20 minutes worth of data logging. At the end of a test session, if you unload the ECU, you will get the last 20 minutes. Now, if, for instance, you were a circuit racer and you went around the track and you did some wonderful lap times and the car was going really well, and then there was a crash and it took you a long time to come back from the crash, not your crash necessarily, but it was on the other side of the track and it was blocked, and you had to idle back slowly. And if you idled all the way back to the pits and got in and downloaded the logging, you would get a nice amount of logging information of the idle. So the logging itself, when configured normally, it will always get the last available, in my example case of 20 minutes. So you need to be careful about how you use the vehicle or how you do your testing, and think about how much logging time you've got. So first of all, what do we log? We're into our logging setup in the ECU. We'll just go back to that actually. The way to get to that, as you can see on screen there, is it's in the adjust menu, of course, down to data logging. And then on the right hand side we get presented with some start stop parameters, which we'll do shortly, and some save and recall import export facilities, which again we'll come back to. But effectively we have groups of things that you can log, and you go into each group and make choices about whether you want to log them or not. So what to choose? This is a screen capture of the first group, which is our basic engines. If you look on the right hand side, you'll see the first one to come up in the list on this screen anyway is RPM. Now by typing in a number here, what that tells the ECU is this is the number of times per second you want the ECU to log the RPM channel. Okay, so if you type in a 1, that means 1 time per second log the inlet air temperature. If you type in a 0, that means do not log, in this case, the exhaust manifold pressure. So by going through the list of channels, and there's literally hundreds, you can form or instruct the ECU what to do. Okay, now this is highly dependent on what the engine is, what it's being used for. Is this a ramp run on a dyno that lasts for 10 seconds? Or is this a long distance race that's going to last for most of the day? So you'll compromise on the things that you will log and the speed that you will log them at, depending on the use of the engine. Now, if this engine has drive-by-wire, then we probably should log some drive-by-wire type sensors, stuff relating to drive-by-wire or electronic throttle. If it doesn't have it, then why log it? Some basics that you would start with would be certainly all the engine sensors. If the engine has an exhaust temp sensor, then log it. If it doesn't, then don't. I'd also be always wanting to know my cut levels. So what that means is the ignition and fuel are often used for RPM limiting, traction control, launch control, dual RPM launch for drags. Lots of different features in the ECU use the cutting of ignition or fuel. So sometimes if we're looking for a problem of a misfire, it's always useful to be able to see if the ECU itself has been cutting the ignition for some reason. So I like to log those. Injector duty cycles, certainly for tuning, unless the vehicle has been set up for quite a while, certainly as a tuner we would always look at injector duty cycle. This will let us know if while you're tuning or at any time the injector duty is going to run out, or anything greater than 90% would give me cause for concern. So certainly tune related log sets would want that channel. Injector pulse width is another useful item to log. We're often referred to that when you're looking for a problem, maybe the engine's running too rich or too lean, and if we see the injector pulse width changing dramatically, well, that allows us to look in that direction, look and see if there's like an unusual fuel comp happening, something like that. If the lambda or the mixture is changing a lot, yet the injector duty cycle or the pulse width is similar, is remaining constant, then the inaccurate air-fuel ratio or the problem with the mixture is potentially for another reason other than being controlled by the ECU, maybe an air leak or a boost hose collapsing or something like that. Ignition advance is another one good to log, and I'm probably a little bit biased on the tuning side of it here, but you don't need to log it fast, but it's useful to keep an eye on it and just make sure there's no unusual amounts of ignition timing going into the end times you don't think there should be. So in other words, a lot of timing going in under boost for some reason. If you log ignition advance, you can see that happening and try and hunt out in the tune-up why. All log sets should have some errors logged. This allows you to see if there's any problems happening with the engine. Now there's a multitude of errors that you can log, but the most commonly used sensors to log or errors to log are in groups 1, 6 and 10. And when you go to the error group page and you press F1, as everyone knows means the help, you will see what is listed in each error group. Now I can tell from memory that error group 10 is all the injector errors. So basically if you log error group 10, if there's any problem with any injector, and each injector actually has 3 different diagnostic error possibilities, the error group 10 logs all of those on all the injectors. So just by logging that one item, this allows you to gather all those errors in. So as I say, 1, 6 and 10 are the common ones. That's the common engine sensors, ref sync sensors, things like that. And status groups, this is things like logging on and off, anti-lag on and off, things that are switched. One of the particular status groups that's useful is status group 1, and in that is a ref sync synchronized. And what that lets us see in the logging is when the ECU actually synced up. Now, history has told us that customers sometimes have problems getting the engines to start properly and have problems getting that part of the ECU configuration set up. So it's really useful for us to be able to see when the ECU actually synced up. In other words, when the ECU started firing the ignition and the fuel. If we can see that happening in the logging and the thing still doesn't go, then we have an idea that it's maybe a fuel setting or a timing setting, and rather than a ref sync type setup problem. So that's the basics of where you'd want to start. But anything that is connected to the ECU, that's measured into the ECU, you need to start with that primarily and look at those other options as you go. Now, how fast do we log them once we choose which items to log? In the ideal world, I'm told that you should log a sensor at twice the rate that it updates, or at least as fast as it updates. So something that updates very quickly like RPM, then you'd want to log that at a minimum of 20, and have the time, then you could log it at 50 Hertz. That gives you good resolution and allows you to see if the RPM is suffering from spikes from inaccurate crank pickups and things like that, or big dips in the RPM for other problems. So the faster you log it, the more things that you can see in the logging. However, having said that, if you have something that changes slowly, like a temperature channel, so our inlet air temp channel, you'll see in this case is logged at 1 time a second. And that's because the inlet air temperature doesn't change a lot faster than that, maybe 2 or 3 times a second. So depending on whether it's measuring just an ambient temperature outside or whether it's measuring boost, you may bump that to 2 or maybe 5 times a second. But 1 to 2 times a second for a temperature-based channel is probably a good start. Things that also, the lambda here is logged at 10 Hertz in this example. That's a little slow. A lambda sensor, I think, changes at something like 25 times a second. So in an ideal world, you might log that at 20 to 50 times a second and see all the information. But remember, the faster you log your channels and the more channels you log, the less logging time you get. Now, this logging time will show up on the bottom of your screen when you're live, and there'll be an example of this shortly. So what you need to determine, though, before you even start this, is how much logging time do you actually want or need at this point. Everyone wants a lot of logging time for sure, and if you need lots of things logged, and if you need them logged over a long period of time, you should consider buying one of our dedicated data loggers, like our Sports Dash Logger or our Advanced Dash Logger. These have now 250 meg of logging in them rather than like the M400's half a meg. So we need to determine how much time we really need as a bare minimum, how much logging time. So if you're going out for a 10-minute test session, I'd suggest to you that you'd probably want to have 10 minutes worth of logging, at least maybe 11 or 12. So we configure our channels to come up with at least 10 minutes worth of logging time. And on some of our channels, we'll need to compromise. So if the engine's tuned, and this is merely just a driver's session, then we don't need to log RPM at 50 Hertz and lambda at 50 Hertz. But we'll need to log them fast enough so that we can just keep an eye on the tune. So experience will determine just exactly what your minimum numbers will be here. But as I say, down the bottom, you'll see your time disappearing as you add more things. Now you can maximize your logging with start and stop conditions. So there is a setup in the ECU, again, that we'll get to shortly, that allows you to turn the logging on and off by specifying a particular RPM to start and stop at. So what this means is that if you do have a long idle period where you have to come in and the car has to be run for quite a while after your test session, and a good example of this actually is some recent testing we did on jet skis, boats, things like that, where you often have to go through a 5-knot period to come back to the trailer. So sometimes that might last 5 or 10 minutes before you can get out to a point on the water where you can open up the engine. So in that particular case, we can configure the logging to only start from when RPM is above a certain number. And we'll get to that shortly. Right, what I want to show you is what logging looks like if you don't log it at the correct speed. So I've just got a simple capture here of 3 channels. Now the top one's RPM, and you'll see in this case the cursor's sat at the RPM of 5,807, and in our logging software i2 I've looked up the channel and I've shown you here on this capture that the logging on the RPM was at 20 Hertz, which is an average log time or log speed for that channel. And you'll see the line on this is relatively smooth. It looks believable, goes up and down as you might expect the engine to be doing. Now underneath in our second panel I have 2 channels, and this is from an electronic throttle engine. And on this engine, on an electronic throttle engine, you end up with actually 4 throttle position channels, but I've got 2 of them here. So one is throttle position, and that's actually from the position of the butterfly, and the other one is from the position that the driver, the pedal in the car, so that's called throttle position driver. So these are logged at different rates, so you can see the difference in the data logging. Now even 10 Hertz is actually realistically, certainly for racing, it's a little bit slow for throttle position. And I can tell that when I look at the green line. It's very chunky and moves in what I would call chunky, abrupt manner, not smooth. But when we look at the purple line here, which is the driver's pedal, and these 2 lines, by the way, should be the same. If you logged each of these at 50 Hertz, they would appear as one line. So when we log something at once a second, and this screen is actually captured out to be looks like about 8 seconds worth. The data points, and in fact I can see them on the purple line. There's a data point here, and the software just draws a straight line to the next capture point there, then there, then there. So you can see that the data actually missing the reality. The green line is reality. So this is logged faster, 10 times faster at 10 Hertz, and you can see that what's actually happening is completely different. So the faster you log, the more things you will see. So in this case, 1 time a second for a throttle position sensor is way too slow. It gives you an indication some of the time of where the driver has his foot, but not ideal. So even 10 Hertz, like I say, for throttle position is a little bit underlogged. However, if we need an hour's worth of logging, maybe you have to compromise this. Now, we've showed underlogging, so what does overlogging look like? Well, overlogging on a channel isn't ordinarily bad. All it is a waste. So if RPM was logged at 200 times a second, the line would just be incredibly smooth, but wouldn't look a lot different to that. The only problem is logging it at 200 times a second means your amount of log time will be reduced. But one thing that does happen when you overlog is that you end up getting multiple samples of the same number. So on this exhaust temp sensor here, you can see that it kind of looks like stairs where the temperature doesn't update that quickly. So at one particular point around 300 degrees, we have a whole lot of data points of exactly the same value. So what that does is makes the data look like stairs. Again, it's just showing you that you're wasting your logging time. So The exhaust temp sensor updates between 5 and 10 times a second, so if you're logging it around that, you'll see equivalent information without wasting your logging time. Alright, how many channels can you log in an ECU? You'll see, in fact, as you go through your configuration, it keeps reminding you that you only have 64 channels. And when I say only, that's actually a large number of channels. Once you get to 64, and when you're on your laptop screen, you can see down the bottom your channels updating as you do them. Now, this keeps going up. You can see this even offline. So offline, you can keep adding numbers beside channels, and these numbers will keep going up. So once you get to 64, it actually lets you keep configuring, but what happens is that those channels won't get logged. So you'll go to download the logging and you'll say, oh, where is my error group 11, or where is my exhaust temp sensor that I added? And if you can't see it, perhaps go back and have a look just how many logged items you have. So basically you can log anything in the ECU, just no more than 64 different things. The next thing that does appear only when you're online is logging time. Now some people might say, why is that? What happens is that you have to go online to the ECU for the software to know how much logging memory you've got. Once it knows how much logging memory you've got, it's able to make a calculation of exactly how much time you will have. So in this example here, once we're connected, we can see for the configuration that we used on the screen capture that we have 1,292 seconds worth of logging. Don't ask me why that doesn't come up in minutes. I haven't had a good answer yet. However, most people do like to know that in minutes, so unfortunately you'll have to get out your calculator and work out what that is. So in our example here, 1,292 divided by 60 equals 21 and a half minutes. So as we increase the frequency or increase the channel number, or channel numbers, the number of things you log, this time here will go down. And what that means is the actual logging time will decrease as you increase frequency in channels. So if you want the maximum amount of use from your logging, then you can make good use of that with the start and stop conditions. Now, as the ECU arrives to you with its start file, it will have a standard start and stop configuration in it. And currently, you can see here that our start RPM is 200. So what that means is, as soon as the ECU detects that the RPM is above 200 revs, it will start logging. And that will be true if you keep the start delay at 0. So the start conditions here are twofold. So ECU has to be over 200 RPM and the start delay has to be past its number. So in this case here it's 0. So you could put a number of 20 in the start delay, and so what that means is the engine has to be more than 200 RPM and 20 seconds before the logging will basically turn on. Now, similar conditions for the stopping of the logging. So in this case, the stop RPM is 100 and the stop delay is 20. So what this means is, as the engine comes to a stop and goes under 100 RPM, for 20 seconds, the engine parameters or your logging parameters will continue to be logged. That allows you to see if the thing might block heat or anything else is happening. And perhaps it's been turned off or stalled for a particular reason. You can see how long the customer's taking to start it again. So by configuring these numbers means you can isolate your logging on and off. So in my earlier example, where we had a jet ski that had to go out through a 5 knot area, I made the start RPM 3,500 because the customer had to keep it under that kind of RPM to keep it in the 5 knot range, and I had the start happening instantly, and the stop RPM I had something like, and it must be below the start RPM obviously, at 2,800 or 2,900. So you use these two parameters to specify a window for when you want the logging to operate. Now there is actually another way of saving your logging, or of defining your logging. You can actually configure an on-off switch or a logging enable switch. And what that does is basically when the switch is on, it logs, and when the switch is off, it doesn't. So that enables the customer to, at any time, to turn the switch on. So if he's out testing in his car and he comes across a nice piece of road, and not that anyone would ever speed on a public road, but just he does happen to find a piece of road that he wants to do some testing, he can flick the switch and conduct his test, and then flick the switch off again at the end of it, and then drive through some more traffic and maybe find another particular part of the countryside that he wants to do some more testing with. So it allows you to go out maybe all day and get selected data logging at your determination, and simply by turning the switch on and off will determine when the logging works and doesn't work. Now, just to show you quickly how to do that, and that's a very simple feature. All you simply need to do is wire into a spare digital input, a switch, could be a button, could be anything, and between that switch and a digital input you wire it back to 0 volts and configure that digital input as number 11, and I've already done that here, and it comes up as logging enable. And in the parameters, if you wanted to go in and have a look, it simply tells you, do you want the logging enable to switch when the voltage is low, i.e. the switch is on, when the voltage is high. So sometimes people are using pre-configured switches that are used for something else on the vehicle, and you can actually use it for two things. So that allows you to maybe turn the logging on when the switch is off. Okay. Now, you put probably a fair bit of effort into getting all this set up, and maybe it's a log set that you want to use for maybe one particular type of racing, and you have another log set that you want to use for maybe long distance racing. So one log set for short distance sprint events and another for long distance 3-hour events. So you can actually save this entire setup, simple Windows type save, and that's found in that top 3 parameters of the setup. So you can export it and just save it like a normal Windows file into a folder, put your own name on it, and at any time obviously the same thing applies. If you want to bring it in, you just go to import, up your particular file name, and in that log set comes, and it saves you going through and setting it up. You might always want to check and go through just in case you've added an extra sensor, but that in itself is, if you're not going to be doing anything extra like that, it's a nice simple way of just changing all the logging to suit your application. It's also a useful feature for our technical guys and people in the field that are looking after other customers. Often that you will have a diagnostic set, and it will be logging all the diagnostic errors and statuses all really quickly, and we can send that file to the customer. The customer can drop that log set or that saved name into a folder and then just import it in, rather than us going through channel by channel, number by number over the phone. So that's, as I say, it's a way of doing it. Alright, that covers the basics of our setup for data logging in an ECU. Thank you for your attention today. If you've got any questions, we'll stay online after the webinar is complete and we can answer those. Otherwise, thanks for attending.